Topic for today is divisibility rule. You can call it rules because we'll be talking about different numbers. So सबसे पहले तो tell me, how do you identify that whether a number is divisible by 2? कोई बताओ मुझे?
Sir,
Anyone?
it has to be a even number.
It has to be a even number. That means the number should last with the last digit. Last digit should be
0246.
0, 2, 4, 6, 8. ना ये. And what about 4? How do you identify that a number is divisible by 4?
Last two digits of the number should be divisible by 4.
Last two digits of the number should be divisible by 4. That means last two digits should be either 0, 0, 0, 4, um, anything like this. है ना? 24, 84. All these numbers will be divisible by 4. So there are 25 pairs, है ना, which are there. So with this, keeping this in mind, can we also say that the divisibility rule is that the divisibility rule for 2 is the last digit should be divisible by 2? Let me give you another example. Let's take 8. What should be the divisibility rule of 8?
Last three digits.
Last three digits should be divisible by 8. And then what about 16? For this, it will be last 4 digit should be divisible by 16. And so on. You can also make a rule for 32 that last 5 digits should be divisible by 32. So how we are getting that? And how we can actually explain that how it is happening. So let's take the divisibility rule of 4 first. Any number like 2, 3, 5, 7, 2. Let's say this is a number. We can divide this number into two parts. 23500 plus 72. And what I know is 4 divides any 100. Yeah? 4 divides any 100. So it was like any 10 can be divided into the 10 is 2 into 5. 100 is 2 square into 5 square. 1000 is 2 cube into 5 cube. Yeah. Last 4 digit, then 10,000 is 2 to the power 4 into 5 to the power 4. And then lakh is 2 to the power 5 into 5 to the power 5. So any 100 which has two zeros, it will be divided by 4. So this number can be divided into two parts. One which is like you are confirmed that it will be divided by 4. You just need to check this. Similarly, if you want to check for 8 for the same number, you will divide the same number into two parts as 2, 3, 000 and other as 572. So what I know now is 8 will divide this. You just need to check this. No? So here what do we see that this number is divisible by 4, but this number is not divisible by 8. So it is not divisible by 8. Because the last three, because this number is divisible by 8, but this is not. Similarly, for if you want to check something for 16, hmm, what you have to do is, let's say this is the number. So what you have to do is, you have to change this number into two parts and 4432, and you just have to check this, that whether this number is divisible by 16 or not. Huh, let me write it. So now I'm saying that this is divisible by 16 and this is also divisible by 16. So this number is divisible by 16. So is it clear to everyone?
Yes, sir.
Hmm? सब लोग बोलो, तरुण, विनय, नक्षत्र, everybody should participate in the class. Okay.
Yes, sir.
So now I'll go for, we have covered 2, 4, 8 and other 16 and similar numbers. Now I will go for 3 and 9. So what is the divisibility rule for 3?
Sum of all the digits of the number should be divisible.
Hmm. Sum of all the digits of the number should be divisible by 3. And rule for 9 is, it is same as 3, that sum of all the digits of the number should be divisible by 9. So how to explain this? Like how we can explain that this will always happen? So let me take a number, like I have taken 5, 4, 2, 7. I have this number. So this number can be can be break into can be broken into this. So I divided the number into 4 parts, and I know that any 10, 100,000 or 10,000, all such number when divided by 3 will always give you a remainder 1. Okay. So this we know that 9 is divisible by 3, 99 is divisible by 3, 999 is divisible by 3, 4 times 9 is divisible by 3. So all such numbers are divisible, when divided by 3 will give you remainder 1. So what I'll do here, I'll count the remainders which are there with every terms. So since 1000 will give you remainder 1, 5000 will give you remainder 5. So I'm not breaking this 5, as you can say that sir 5 will give remainder 2 also. So but I'm just keeping it as 5 to create this formula. Similarly, 100 will give remainder of 1, then 400 will give you remainder 4, 20 will give you remainder 2, and 7 will keep as it is. So the all the things that all the parts of the number which we did not divided it by 3 was 5 plus 4 plus 2 plus 7. And if this is divisible by 3, the number is divisible by 3, or whatever the remainder you will get here, you will get the remainder here also. Okay. So similarly, if you want to explain the divisibility rule of 9, it will be similar, that 9 is divisible by 3. 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 9 is div Let's say I'm keeping here as this. So the number is now 5000 plus 400 plus 10 plus 5. And I'm dividing it by 9. So if we divide it by 9, 5000 will give you remainder 5. 4000 will give you remainder 4. 400 will give you remainder 4. 10 will give you remainder 1 and 5 as it is. So if 5 plus 4 plus 1 plus 5, if it is divisible by 9, then the number is divisible. And since this is not divisible by 9, and you will having remainder 6, that means through this division, you will also get the remainder 6. Is it okay for everyone? Did you now understood that? Did you now understand that why we have these divisibility rules? Nakshatra,
Yes, sir.
Mohi, Tarun, Vinay, everybody.
Yes,
Yes,
sir.
sir.
Yes, sir.
Very good. So now we'll go for 7, 11, and 13. So there is a different rule for 7 also, but that is not very mandatory, or you may not, you may ignore that. 7, 11, and 13 will have a divisibility rule for all these three in one formula or one concept. So what do we get after dividing 7, 11, and 13? And this is very important because many of the questions will be based on this. And you might get a question based on this also in your exam. So this particular concept sometimes help a lot in solving questions from exam also. So what will be the multiplication here? What will you get here? 1001. And somebody check this on calculator.
Yes, sir.
I get 1001. Now finding a multiple of 1001 is very easy. Like any number, single digit number, if a single digit number, if a single digit number gets multiplied by 10001, what will we get? So a into 1001, you will get A00A. So 9 into 1001 will give you 9009. If it is a double digit number, AB into 1001, you will get AB0AB. So now you can say that 72072. If this is a number, it is divisible by 7, 11, and 13, all three. Because it is a multiple of, or this can be divided into 72 into 10001. If a 3-digit number multiplies this, three-digit number is there, then ABC into 1001, you will be getting a number ABC, ABC. So now you can also say that 123, 123. If we divide this number by 7, 11, and 13, you won't get any remainder. It will be a divisible number. from all these three. So actually you can break the number. Like if somebody is asking whether 73259 is divisible by 13 or not. So we can break the number into two parts, 73073 plus plus what? 27, 186. So now if we'll divide it by 13, it will be divisible by 13, and just you have to check this, and whatever the remainder is there, you will get the remainder here also. So this is how you can actually check any number, that whether it is divisible by 7 and 13 and
Sir,
11 also, but for 11 we have a different way also. हाँ बताओ.
सर इसमें हम 73,000 करके नहीं ले सकते थे वैसे?
73,000 मतलब
जैसे आपने इसको 73073 करके ब्रेक
वो
किया.
इसलिए ना, बिकॉज ये फॉर्मेट कौन सा है, ये फॉर्मेट है AB0AB, है ना.
अच्छा.
How did we get this format? We get this format by multiplying AB into 1001. So since this format actually confirms that you have uh, you have this number which is divisible by 7, 11 and 13. So that's why I divided or extracted this from this number. ठीक है.
Yes.
अब जैसे एग्जाम्पल देखो, जरूरी नहीं कि आगे बढ़े, हम पीछे भी जा सकते. जैसे अगर कोई तुमसे बोलता है 73060, है ना. अब ये नंबर जो है बेसिकली it is less than 730 minus 13. So what I know that this number is divisible by 13 and this number is also divisible by 13. Ultimately this number will be divisible by 13. ठीक है.
Yes, sir.
So for 7 and 11 you will be using this. For 11, and there is a separate rule for 7 also, you don't have to remember that, है ना. Because this basically no one will ask question that whether this number is divisible by 7 or 11 or not. They will be asking you some concept based question based on the divisibility rule. Okay. So now for 11, there is a divisibility rule. Difference of sum of odd places and even places. If this is divisible by 11, then the number is divisible by 11 also. Like, let's say I have a number. Let's say I have a number what? 7 1 and 191. This is a number that I have written here. We could have checked from this rule also, but I'll be using this method. So I'll find all the odd places. These are the odd places. And एक second, make it 2. Okay. So these are the odd places and these are the even places. So what do we see? That all the odd places will sums up to 10 and difference of all the even places will be 1 plus 9, 10 again. So 10 minus 10. So the concept was either it is divisible by 11 or 0. Okay. So here what we are getting 0, which is again the like multiple of 11 only. So this number 71192 is divisible by 11. So there is a certain logic behind this rule also. This will be homework for you. I'm not telling it because it's not very much important here, but you will tell me in the next class that why we have used this to check the divisibility for 11. Now, all these numbers that uh, I tried to find the divisibility rule were either prime numbers or multiple of prime numbers, matlab, like power of prime numbers like 2, 4, 8, 16, or 3, 9. So now I'll check or I'll create a divisibility rule for composite numbers. So like 6. And acha, for 5, you all know. For 5, what should it be? Either 0 or 5, because the last digit should be divisible by 5 or 0. Because any 10 is divisible by 5. The last digit should be 0 or 5. So what about 6? So I'll divide it into two parts, 2 into 3. And since there is no common factor between 2 and 3, these two are co-prime. So any number, if it is divisible by 2 and 3, both, then it will be divisible by 6 also. But remember that this rule applied, you can apply this only when you have two co-prime factors of the number. Similarly, let's say if you want to check the divisibility rule of 12, so that number should be divisible by 4 and 3 separately. If you want to check the divisibility rule of, let's say, 21, this number should be divisible by 3 and 7, co-prime, because if a number gets divided by 3 as well as 7 itself, 7, then it will be divisible by 21 also. But if a number is like, let's say, 18, so you can't say that whether if the number gets divided by 6 as well as 3, then it will be divided by 18 also, because these two are not co-prime. So if you want to check a number whether it is divisible by 18 or not, you have to divide 18 into two parts which are co-prime to each other, like 2 and 9. Okay. So everyone got this?
Yes, sir.
Yes, sir.
Okay. So now we'll go for the fact that we were talking about, that 2 into 5 makes 1, matlab 10, like 1 0. So if a number has prime factorization like this, like if a prime factor, if a number, if n's prime factorization is 2 power cube into 3 power 4 into 5 to the power 2 into 7. So this, how many 0 will be in last for this number, or how many like how many zeros will be there in this number in the last of the number?
2.
2, because we have 2 5 here and more than 2 3 years. So whatever is less, like 2 and 5, whatever is less, will be taking that number. Basically, we have to find all the pairs that exist as 2 into 5. So we have two pair which exist here. So we'll be saying that it will have two zeros in the last. So with this definition and with this explanation, if somebody is asking you that how many number of zeros will be there in 100 factorial. So if you don't know about factorial, I'll just write it here. 3 factorial is 3 into 2 into 1. And similarly, if someone is saying that 10 factorial, it means 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. All this. So number of zeros in 100 factorial. So basically, I cannot easily prime factorize it. It's tough here. Prime factorization is tough here. You cannot easily prime factorize this number. Then what we should do now? So I know that even if we'll do the prime factorization, the only thing that matters is 2 pi power and 5 pi power. And whichever is less, है ना? And the number of that 5, whichever is less, will determine that how many zeros will be there. So when we will write 100 factorial as 100 into 99 into 98, let me write in a straightforward way, like ascending order. 1 into 2 into 3 into 4 into 5 and so on, into 6 into 7 into 8 and so on till 99 into 100. So what do you see? Which will be more in numbers? Power of 2 or power of 5?
Power of 2.
Power of 2, because every second number is giving 1 to you. So every second number is giving 2, and every fourth number is giving 1 extra 2. Every eighth number is giving 1 more extra 2. Every 16th number will give you 1 more extra 2. So we will have more 2s than 5. Basically, what we need to find is how many 5 are there in 100 factorials. So I know that every fifth number will have 1 5. So since 100 is divisible by 5, so even if it was not divisible by 5, we should have taken integer value only. Like the same question may be asked as 102 factorial. So the only thing is being added here 101 into 102. So basically, if such is the case when it is not divisible by 5, we'll take the integer value here 20. Then I know that every 25, every 25th value will have one more 5. Like 25 can be written as 5 into 5. 50 can be written as 5 into 5 into 2. 75 can be written as 5 into 5 into 3. Like this. So every 25 will have one more 2 and we'll be getting 4 from here. Then every 125 will give you one more 5. So since 102 is less than 125, so we'll not be considering that. So the total number of 5 that we are getting here is how many? 24.
सर ये
So
नहीं समझ आया.
नहीं समझ में आया? चलो हम दो वाला भी काउंट करते हैं. Let's count for power of 2 also. Like if we will write 100 factorial or 102 factorial, let me go with this only. How many, what power will have, 2 will have what power? And what power of 2 will be there if we'll do the prime factorization of 102 factorial? So what you can see here that every second number has 2. Yani 102 will give you 102 divided by 2 as number of 2. Then we also see that every fourth number has one extra 2. So 102 divided by 4 will give me one extra. These are the numbers where we'll get me as extra 2. Then I see that every eighth number will have one extra 2. Similarly, every 16th number will have extra 2. Every 32nd number will have one more 2. Every 64th number will have one more 2. And every 128 would have one more 2, but 102 is less than 128, so we'll not be counting it. So these are the number of 2 which will be there as power. So here I'm getting 51, here I'm getting 25. Here I'll be getting 12, only integer. We'll be taking only integer. 6, 3, and 1. So the total number or the total power of 2 will be 51 plus 25, 76, 76 plus 12, 88, 88 plus 6, 94, 94 plus 3, 97, 97 plus 1, 98. So this will be the power when 102 factorial will be written in prime factorization. 2 to the power 98 will be there. Similarly, we don't know about 3 yet. Then 5 will have power of 24. Are you getting right now?
Yes, sir.
So how did we count it? The power of 4? Like every
Sir,
fifth number. हाँ.
सर मुझे ये नहीं समझ आया कि हमें ये आपको कैसे पता चला डिवाइडेड बाय 5 फिर 25 फिर 120.
क्योंकि हर पांचवें नंबर पे 5 है ना. तो 100 में कितने 5 होंगे वही काउंट करना है हमें.
सर ऐसे फिर दूसरे वाले में 102 बाय 10 नहीं आना चाहिए.
10/10 नहीं, 10 तो 2 into 5 से बनता है ना. So what I know is if I find the number of 5 and number of 2s, I can make the pairs. जैसे रुको, let me ask you this question. 5 into 15 into 25 into 35 into 45 into 55 into 65 into 75 into 85 into 95 into 2 to the power 8. How many zeros will be there? So I know I have to count number of pairs exist for 2 and 5. 1, 2 and 1, 5 gives you 1, 0. Right?
Yes.
So here I know that number of 5 is much more than number of 2. Because every number is giving you 5. Even the 25 gives you 2, 5. Similarly, 75 gives you 2, 5. And the power of 2 is just 8. So this number will have total 8 0 in the last of it. Right?
8 पावर में है इसलिए 8 zeros.
Because we have more 5 than 8 or more 5 than 2. So I will just count number of 2. समझ में आई बात?
Yes, sir.
तो अब मुझे एक बार बता ही दो. If I would have asked that, अब इसको एक क्वेश्चन हम ऐसे अगर ड्राफ्ट किए होते या कोई तुम्हें ड्राफ्ट करता कि देखो कितना बस चेंज कर देने से, वर्ड चेंज कर देने से क्वेश्चन अलग लगता है, बट अल्टीमेटली इट इज सेम. 100 डिवाइडेड बाई 3 पे पावर x leaves no remainder. Leaves no remainder. What will be maximum value of 3, sorry x? ये देख रहे हो, ये सेम क्वेश्चन नहीं है.
जीरो.
हमें नहीं, जीरो नहीं है. जीरो बोल रहे हो क्या? जीरो नहीं, हमें सॉरी 100 डिवाइडेड बाई, सॉरी सॉरी, हाँ यहाँ तो जीरो ही होगा. whosoever responded was ये 100 factorial. 100 factorial divided by 3 power x. How much, मतलब it will leave no remainder. What will be the maximum value of x? So basically, you have to find that 100 factorial. If I'll write this in prime factorization way, what will be the power of 3 that it will have? And that will be the maximum value of x. So in order to find power of 3 into factorial, I'll visualize like this. So I know every third number will give you a 3. Then every ninth number will give you one more 3. Then every 27th, you know na, 3 into 3 9 hota hai. 3 into 3 into 3 is 27 hota hai. So every ninth number will give you
27.
one. Every 27th number will give you one more 3. Similarly, every 81 number will give you one more 3. And I cannot take the next power of 3 because next power of 3 is 243. So the power of 3 that I am getting from this is 33. I'll take the integer part. 11, 3, and 1. 44 plus 4, 48. So x will have maximum value of 48. Is it okay?
Yes, yes, sir.
तो आपके लिए एक होमवर्क है कि let 100, not 100. Let me give you a smaller number. इसका प्राइम फैक्टराइजेशन करके लाना. You have to do prime factorization of 50 पे फैक्टोरियल. ठीक है, ठीक है ये.